Okay, we have a 2023 Forest River Heritage Blend. Customer complaint is that the slide room does not do anything when you press the switch, as you can see. So the first thing you want to do is check power. This is the exact slide system that has 2 independent motors. It's a cable slide. So first thing you want to do is see if you have power coming to the switch, and if you do, see if you have power going out from the switch, which requires removing this panel, 6 screws. It comes out. Got power probe, I've checked that. The next thing you have to do is to remove the fireplace, because as you can see, that's where the controller is located, and power measurements need to be taken from there because it has its own power. So to remove the fireplace, there's going to be 2 screws that hold the faceplate on. They're going to be going through those brackets. Then you can lift up on the glass. As you can see, it has the hooks. They hook onto the fireplace here. And then you can take the glass out so that you can expose the mounting screws for the fireplace. 4 more square head number 2s. Take that out, and then the whole fireplace comes out. Once we do that, we can come in here with our probe and check for power. This controller has power of its own, and you can come in here and check for that power. Using your probe, and that's going to be on the blue and purple. So you can see we have our ground, and we have our power. Okay, and then you do the same thing to test the switch. While you're holding the switch down, you check to see if you have. So as you can hear the beeps. If you can't see it, just push it down. So when I'm holding the switch down, which is what I'm doing, so I have power coming through from my switch into the controller, and the controller has its power, which it's going to use to switch over to the motors. So the part that's not working is the controller, when it gets the switch input, is never sending the power to the motors, and it has 2 override buttons. See, motor 2 in, motor 1 in. The override buttons, they're not working either. So definitely have a bad controller on this. So the next item will be the Coleman Mod AC, which is not working. It comes on, but it's not cooling. The compressor never engages. I've had this running while I was diagnosing the slide because it needs to be running for about 15 minutes. I have it on high cool, set at 33 degrees, the lowest setting. Currently it's 64 degrees in here. So now I'll go ahead and start doing my performance test and take down that documentation for this warranty claim. Okay, beginning the performance evaluation of the AC unit. Performance test starts with taking temperature readings of ambient temperature versus discharge temperature, your supply, and performing a calculation to come up with your delta T. I'm using the Kaiweets DMM with measurements of temperature. It has a temperature function. Start off by turning on the meter and then set it to temperature. on this meter, it will tell you where to hook the probes. So it's flashing for the probes to be connected here. I'll just connect them where they go, red and black. All right. You're not supposed to use those infrared temperatures to do this. They want you to use a real thermometer or electronic thermometer. As you can see, our thermostat is saying 65, and our ambient temperature here in the slide room is climbing. Currently it's at 57. These measurements need to be taken at the intake. So at my intake, the actual air being drawn into the system, I'm getting closer to what my thermostat is reading, and I'm about at 60 degrees. So my intake temperature is 60 degrees. Now I need to test my discharge or my supply, and my supply temperature is also 59 degrees, so there is no change. Even though the setting, I have the AC set to 33 degrees, which is the lowest setting. So the compressor is not engaging, but at this point, I'm just taking my measurements, and you can see that fluctuated to 60 degrees. Okay, so the next step is to go on top of the roof and take electrical tests and measurements, starting with voltage. So now I will remove my temperature probe, and we're still at 60 degrees. So the return and the supply are the same temperature, which means that the cooling unit is not cooling. So now we need to go on top and see why. All right, we got the backpack loaded out so we can go up top and work with the air conditioner. We have the ladder set up. I'll put on the backpack and we will climb the ladder. The combination of the backpack and the pass-through ladder makes it easy to navigate with all the tools. Okay, so this is 2023 model. This is a Coleman Mach AC Mach 15. So it's going to be 15,000 BTUs. Find a spot. Put the bag down, and we'll start taking this apart and get to the electron. All right, so on this model, you got number 3 screws on the top and number 2 down here. Alright, so that's how they chose to do it. Normally you just have 4 on the top, but on this one there's only 2 over here, and then the other 2 are down here. Don't try to force it. Now, because I have a high-end clamp meter, this Fluke 377 FC, I don't have to pierce any wires or make any crazy connections. I can simply set up my meter, and I'm going to use the field sense working with AC. This does require you to have, so you can get your hertz, to have the ground hooked up. So I have the ground lead here, and I'm going to connect that just to any of the copper, because that's going to be a good ground. And then I'm going to test my wires on this compressor. My amp clamp. because the has to be grounded to get the voltage measurements. My compressor is not running at all. It's not even hot. So I'm definitely going to be taking a look at the capacitors. This should be a good ground. Now I know the fan is moving, so let's grab something from the fan and see if we can get a reading on that. Gonna be the brown wire. So as you can see with the field sense, we got a good brown. And on the brown wire, it's saying it has 187 volts fluctuating around AC. So I'm reading the voltage through amp clamp. Not very stable. You kind of have to have it just right away from the other wires, or it affects it. But this fan's pulling about 3 amps. And I'll go back to my compressor wires. Nothing on the black. Nothing on the red. Nothing on the white. So that run capacitor, I'm having an issue with it. So let me take this apart and see what we got going on. Here's the sticker. Alright, so now we're at the capacitors. So compressor is not turning on at all. My cap isn't even getting any power, so I go straight to the purple wire. This wire is the wire that the 110 comes in on for this part of the system, and I have nothing. So I can go in here and I can grab a hold of the brown, and I have what I need to have on that. So as you can see, capacitor is bumping up the voltage. Got my amp draw. So what that tells me is the relay in the control board is not sending the 110 out, and I need to check that, which is like right in here, but you can get to it from the inside. But yeah, this one seems like a control issue. So I will check to see if I have my 12 volt input coming in, and then I will move on from there. Just to be sure, I went ahead and I also used the leads to check it. That's going to definitely be a little more accurate, but I am getting 120 volts coming in on the fan side, getting nothing on the compressor side. Okay, troubleshooting the control box. Up top, I do not have any power 110 coming out on the purple wire, and I still don't down here. Suspect a bad relay. I check my control side. I do have 12 volts on the yellow wire, which is coming from the thermostat. So if we go to volts DC, I take my probe, going into the Wago. Right now the unit is on, and as you can see, I'm inside that yellow lead, which is the Y, which is compressor. thermostat is calling for cool, and that should activate the compressor relay. The compressor relay should have, if I check my control side on the board, I have my voltage 13. So I'm checking the control side of that relay. I'm just doing it from the back of the circuit board. Okay, you can see I have my 13.7 volts. Okay, but it's supposed to engage an electromagnet which closes the 110 side, which are these two posts. Now go back to volts AC. All right, now we're on volts AC, and one side of this should be constant hot. All right, as you can see, I have 120 volts, but on the other side of the relay, nothing, 1.8 volts. So what that tells us is you have a bad relay, and those relays, as you can see, are soldered onto the board. So you have to replace the whole control board. So this is a definitive diagnosis that this control board is bad, specifically the compressor relay.